Before the electric motor, the world relied heavily on steam power, a loud, polluting, and inefficient technology that dominated the Industrial Revolution. These machines required constant supervision, devoured coal, and were prone to mechanical failures. Yet, they powered the factories and transportation systems that drove the 19th century economy. But change was on the horizon. In 1831, Michael Faraday's experiments with electromagnetic induction revealed a new way to generate motion. This discovery laid the groundwork for what would become one of the most transformative inventions in history, the electric motor. Faraday's discovery of electromagnetic induction showed that electricity and magnetism were intertwined. By passing a current through a coil, he could create a magnetic field that produced motion. While this was revolutionary, it was Nikola Tesla who took the concept further. Tesla's development of the alternating current, AC motor, in the late 19th century solved many limitations of direct current, DC, systems. Unlike DC motors, AC motors were more efficient, less expensive to maintain, and could transmit power over long distances. These advancements opened the door to widespread electrification, changing how industries operated and setting the stage for the modern age. At its core, an electric motor is a marvel of simplicity. When electricity flows through a coil, it generates a magnetic field. This field interacts with another magnet, creating motion. The rotor, the moving part, spins within the stator, a stationary magnetic component. Together, they convert electrical energy into mechanical energy. This principle is scalable, allowing electric motors to power everything from tiny smartphone components to massive industrial equipment. The Industrial Revolution entered a new phase with the adoption of electric motors. No longer constrained by the inefficiencies of steam power, factories became more efficient and adaptable. In the automotive industry, Henry Ford's assembly line, powered by electric motors, revolutionized manufacturing. This efficiency reduced production costs and made products like automobiles more accessible to the masses. Electric motors weren't just powering machines. They were fueling economic growth. Today, electric motors are so ingrained in our lives that we hardly notice them. They power household appliances, medical devices, public transportation, and even electric cars. In urban areas, electric motors drive subways and buses, reducing air pollution and making cities more livable. And in rural areas, they power irrigation systems, bringing water to fields and sustaining agriculture. Electric motors are key to the global shift toward renewable energy. Wind turbines, for example, rely on electric motors to convert kinetic energy into electricity. Similarly, solar tracking systems use motors to adjust panels for optimal sunlight exposure, maximizing efficiency. However, the materials used in electric motor production, such as rare earth metals, pose environmental challenges. Mining and processing these materials can be destructive. Innovations in recycling and alternative materials are critical for making electric motors more sustainable. The evolution of electric motors continues to inspire innovation. Brushless DC motors, which are more efficient and durable, are widely used in robotics and drones. These motors enable precision and reliability, essential for tasks ranging from manufacturing to search and rescue operations. In aerospace, electric propulsion systems are being developed for aircraft. These systems promise quieter, more efficient flights with significantly reduced carbon emissions, signaling a new era of aviation. Despite their benefits, electric motors face challenges. The reliance on rare earth metals raises questions about resource availability and environmental impact. To address this, researchers are exploring new materials and designs, such as superconducting motors that minimize energy loss. Looking ahead, the integration of electric motors with AI and IoT systems could revolutionize industries. Imagine motors that self-diagnose issues or adjust performance in real time to optimize energy use. Electric motors may be silent, but their impact is loud and clear. From revolutionizing industries to enabling sustainable energy solutions, these devices are at the heart of progress. They remind us that even the simplest principles, like the interaction of electricity and magnetism, can lead to extraordinary advancements.